Hello everyone, I am Sabri Kumar, studying mechanical engineering in Department of Production Technology at Madras Institute of Technology. So today I am going to give a small presentation video on the topic analysis of different types of high pressure hydraulic fluid bowlers. So come on, let's dive into the topic. So at first, we'll get to know about what is a pressure vessel. A pressure vessel is a closely tight container which is normally in the shape of a spherical or cylindrical, which are designed to hold the fluids, which are gases and liquids, at a substantially greater pressure than that of the ambient pressure or the surrounding pressure. So they are usually made of the carbon steel or stainless steel assembled from the plates of the welding methods. So however, the materials like aluminum and the non-metals can also find the usage in pressure vessel materials in some specific situations. So like in the case of different temperatures, the materials like aluminum and copper are used. So even though the most of the pressure vessels are basically a long cylinder with two heads, they can also uh, take the shape of a spherical or cylindrical. It depends upon the situation. So now let's get into the design of the pressure vessels. The following parameters which are used in the design calculation of pressure vessels are mentioned below, which such as the parameters which are critical in evaluating the wall thickness of the shell and the head of the pressure vessel. So, and the first parameter is the design pressure. The design pressure is the value wherein the vessel specifications are calculated. It is derived from the maximum operating pressure. So, the design pressure, which is used for designing at which range of pressure the pressure vessel can withstand without breaking its original properties. So the second parameter is the maximum allowable working pressure. As it suggests, the maximum allowable working pressure is the highest permissible pressure measured at the top of the equipment, which is the vessel must operate based on the design temperature. So it is the highest pressure that the weakest part the vessel can handle its design temperature. So this is the maximum allowable pressure which can be operated, under which the pressure vessels can be operated. So the next factor is the design temperature. The maximum allowable stress is highly dependent on the temperature. As the strength decreases with the increasing temperature, it also becomes less brittle at very low temperatures. So the temperature and pressure are related at some point. So the range of the temperatures under which the pressure vessels can be designed also matters. So the next factor is the maximum allowable stress. The maximum allowable stress is obtained by multiplying a factor which is a safety factor to that of the maximum value of the stress the material can withstand. So there will be a range of stresses which can vary at a certain points inside that of a pressure vessel. When multiplied with the safety factor, we can get the maximum allowable stress the pressure vessel can withstand. So it's also an important factor for designing the pressure vessel. So the next factor comes into the play is joint efficiency. So the joint efficiency is the ratio of the strength of the welded plate to that of the strength of the unwelded virgin plate. So the pressure vessel, as it contains the cylindrical part as well as the dished end. So there will be a factor called the joint efficiency, which determines the strength of the welded region between the cylindrical part of the pressure vessel, and the dished part of the pressure vessel. So this also plays an important factor in designing of the pressure vessels. So now let's move on to the various type of pressure vessel dish heads. So there are six types of dish heads, namely hemispherical or spherical dish head, or elliptical or ellipsoidal dish head, or spherical dish head, flat dish head, disc head, or conical. So these are the six type of dish heads we are going to discuss on the upcoming slides. So now as you can see, these are the images of the six types of t-shirts, which are the 2D models, 2D images of the t-shirts. So you can see the spherical, hemispherical t-shirts, the test discs, and all the other types of t-shirts. So now let's get to know about each type of dish head individually. So at first, we'll get to know about hemispherical head. So hemispherical heads are a popular choice of pressure vessels due to which the ideal shape which divides the pressure in the vessel equally across the head surface. The elliptical head. The dish radius is approximately 90% of the diameter and the knuckle radius is approximately 17% of the diameter. So it is generally called as the 2:1 elliptical flanged and dished heads or ASME compliant. So ASME refers to the American Standards of Mechanical Engineering. Now let's get to know about the flat dished head. It is the simplest form of pressure vessel heads, but it has the less usefulness in the pressure vessel heads. So it is not preferred as much as that of the other pressure vessel heads. As it has the less pressure withstanding capacity. Torus spherical head. It is also the most widely used among pressure vessel heads because it has the more radial section for the pressure distribution. So it also withstands maximum pressure, but lower than that of the elliptical heads. So it is less economical when considered when compared to the elliptical heads, but it is widely used because of the time which is required for making the torus spherical head is less than that of the elliptical head. Dish disc head. It is the simplest dished head. The manufacturers of the dished heads for the pressure vessels and the tanks requires machines which are able to ensure high performance and high productivity. So usually these type of dish disc heads are not used in the most of the cases, but yet in certain situations, um, because of its low pressure withstanding capacity at the edge points of the dished head. So now the last of the dished heads, toriconical head. The toriconical heads, which are designed in the shape of a concentric cone. The toriconical heads have a knuckle and a straight flange at a wide end of the cone, which are used for high pressure, which are used to withstand the high pressure inside the pressure vessel. So now let's get to know a little about hydraulic filters. As we all know that a filter is a component on a hydraulic fluid systems, which is used for removing contaminants or impurities from the fluid, which can cause defect to the fluid power systems. So now let's get to know about the basic filter hydraulic components. So there are four parts of hydraulic filter components: filter head, filter bowl, the filter element, and the bypass valve. So the filter head, the powdered casing that fluid flow both enters and exits the filter. Additionally, it can also serve as a mounting pad when mounting to a machine, which prevents the filter element from getting damaged. So the filter bowl, the vessel that threads the filter head and contains the protects the element. So it is the casing of the entire filter which prevents the filter element from getting damaged. So the element, the cartridge that holds the filter media, the element which is responsible for trapping the contaminants or the impurities that's entrained in the system fluid. So what's the bypass valve? The valve designed to protect when the filter becomes overloaded with the contaminants and controls the exit and entry of the fluid. So now let's get to know about the materials which is used for making the high pressure hydraulic filter valves. So the various properties they can make certain alloys particularly desirable are very lightweight, very high strength, excellent low temperature performance, exceptional corrosion resistance, ease of fabrication by many techniques like readily assumed through unique structural configurations, has excellent weldability and good machinability. So the aluminium alloy, aluminium 2014 have been used for designing the filter disc heads. And hence finally they are used also for making the entire filter bowls. So now let's get to know about the problem definition. As we all know that a filter is used to produce a clean fluid which may be contaminated due to the external conditions like temperature, dust particles, and the factors by filtering process. So the filter ball head is also one of the crucial part of the filter, which also withstands the hydraulic pressure from outside the filter and holds the filter ball firmly. But the external hydraulic pressure varies, and hence the capability of the filter ball head should also be high so that it protects the element placed inside the filter ball. To determine the suitable ball head to withstand the high pressure with a minimum resultant stress and optimal weight, the analysis need to be performed. So there are basically six type of dish heads, as we all know that. So based on the six type of dish heads, we'll design a individual filter bowl for each type of dish head, and the analysis is performed to get to know about which type of filter bowl is most suitable for making a high pressure hydraulic filter. Now here comes the methodology which is used for solving the problem as I started. Different types of filter ball heads are studied by the properties and stress withstanding capabilities. The resulting stress are formed for the given filter ball heads is found using the theoretical calculations, and then the 2D models and the 3D models of the several dish heads are obtained using the AutoCAD and the Creo software respectively. Now, the 3D models which are designed in the Creo software is used to perform the finite element analysis under FEA under the linear static stress analysis in the ANSYS software. Now, the resulting stress from the theoretical calculation and simulation results from the ANSYS software are compared. Based on the minimum resulting stress and the weight, the suitable filter head for a given filter is decided. Here comes the theoretical calculations. The below mentioned pressure values are the most important for considering the construction of the filter ball heads. Now the pressure values are the operating pressure. It is the pressure in which the filtering process occurs normally with the desired properties such as stress withstanding capability, filtering efficiency, etc. etc. So the next term is the proof pressure, which is the maximum pressure that can cause in change of the performance of the device within the specifications of the filter. Now the third one is the burst pressure. It is the maximum pressure that can cause damage physically to the internal components of the filter element and the filter heads. So now here comes the formulas which are used in the theoretical calculation for calculating the stress in the different type of pressure vessel heads. So there are different formulas for each type of pressure vessel head which are used for calculating the stresses under given conditions. So now, based on the formulas available for the theoretical calculation of the stresses of different type of filter ball heads, the calculation have been performed in the Microsoft Excel and it has been tabulated as follows. So as we can see, there are different type of for the different type of dish heads, different type of stress values are obtained based on their respective formulas, and it has been tabulated as follows. Now, after generating the 3D models of the dished heads in the Creo software, they have been taken. They've been taken to the analysis software, which is ANSYS, and and the material has been given, and the mass of the each dished head as recorded as follows. So now the example of a dished head, the 2D and 3D model of a dished head is shown here, and the elliptical dished head is chosen for this. The 2D model of the uh, elliptical dish head is shown on the left side and the 3D model is shown on the right side, which is the isometric view of the elliptical dish head. So now the design parameters for constructing the elliptical dish head has been given: the internal diameter, the external diameter, the height of the dish head, the crown, the knuckle radius, the straight flange length. These are the design parameters that is used for designing each type of dish head, and here in case of the elliptical dish head, the values are given as an example. So now, after constructing the 3D model of the dished heads in the Creo software, they have been revolved and constructed as a filter ball for the filter ball and the filter ball head for a filter. And now the models have been taken into the ANSYS software, and the linear static finite element analysis is done to study the stresses on the various parts or corners of the filter ball heads, and the screenshot of the analysis the study is depicted as follows. Now, the simulation results which are obtained in the ANSYS software is depicted in the tabular column. The operating pressure, the probe pressure, and the burst pressure in case of an elliptical head. Now, here comes the results. So the mass comparison of the different filter ball heads are depicted in the form of bar graph, and is depicted as follows. Now, the comparison of result for the theoretical and the simulation analysis as follows. As you can see, for the operating pressure, the bar graph of the different type of analysis is mentioned below. The theoretical results are mentioned in the blue bars, and the simulation results are mentioned in the yellow bars. As you can clearly see from the chart, that the simulation results are a little bit higher than that of the theoretical results for each type of dished head. This is in case of an operating pressure. Similarly, in case of the proof pressure and in case of the burst pressure too, we can see that the simulation results are a little bit higher than those that of the theoretical results for all type of dish heads. So this is an important point to be noted in the comparison of the results. So based on the comparison of the results, we can conclude certain points that the hemispherical structure, that is the hemispherical dish head, produces the minimum stress when performed in the three different types of pressures. And the dish disc is the filter bowl head with the lowest mass when compared to that of the other dish heads for a given radius of the filter bowls. So it is depicted in the table column as follows, as we can clearly see. The hemispherical produces the minimum stress, and the dish disc has the least mass, and we can see the flat dish is an optimal one based on considering the factors mass and stresses. We can see the flat disk is an optimal one. So based on the results and the comparison of the results and the discussions, we can arrive at a specific conclusive points. So the first one is considering stress as an important factor. The performance of hemispherical dish head is good for a filter bore head, but when it comes to mass as an important factor, the performance of disk head is better. But the problem is to find the most optimal solution, that is considering both the stress and mass as an important factor. We found that the flat disk head is found to be the most suitable disk head for the present filter bowl head design. Hence, the flat disk head is the most optimal filter bowl head for a given filter for the given filters. So the general suggestion, which can be given based on the conclusion above, is that the fillet or chamfering is done at the joining ends of the dish head to minimize the stress concentration at the joining of the filter bowl cylinder and the dish heads. Thus, it is found that on adding fillet or chamfering to any type of dish head reduces the overall stress concentration on the entire bowl, and hence it provides a better filter bowl for the given filter. So now here comes the learning points which I have acquired from completing this project. That as I have gained a lot of exposure to the basic usage of the computer design and also the construction of 3D models using Creo software, performing finite element analysis at a basic level and ANSYS simulation software. The techniques on approaching and solving problems on designing, and also standard documentation of a solution to the given problem. These are the learning points I have acquired from completing this project. So that's all for the presentation. Thank you.